So welcome everyone. For those I haven't met yet, I'm Jay. It's my pleasure really to welcome you online today, and also welcome those who are going to join us afterwards and watch this recording in the near future. And this is obviously the second session in the CHCSB week of webinars. I'm going to chair this session, and what I'll ask really is that when not speaking or when not asking a question, please just keep yourself muted just to avoid any background noise. And if you do have questions, feel free. Evgenij's quite happy to kind of have you chip in a question if it's relevant to the bit that he's talking about. Feel free to unmute yourself and shout up. But otherwise, you can hold some questions to the end if you prefer, or if you want to put them into the chat bar, and then I can bring them up at some point. That'd be grand. Some of you may have heard today's guest speaker before because he's been kind enough to speak at CHCSB events in the past a couple of times now, as well as at various events internationally. We were quite keen to have him back again to provide some updates on the work that he's doing. So again, he's a researcher at the Swedish University of Agricultural Sciences and undertaking some pretty important work investigating the effects of different flooring systems on gait, on behaviour, and on the biomechanics in dairy cattle. And is currently working on some projects investigating various aspects of hoof health in dairy cattle, focused on several flooring systems and also the different hoof trimming techniques and the kind of interaction. So I'm really pleased to introduce Evgenij Telezhenko. And Evgenij, you've got control. I'll hand over straight to you. Thank you very much.
Okay, thank you. So we can try to share the screen again to see if it works again. You can see it?
Seen, thank you.
Yeah, great. So we are here. I'm glad to be invited again. I thought you were tired of me already, but Tim said it was okay. So I call it, well, it is, as Jay said, that is actually the third time I talk to you. Not exactly to you, but to your organization and to UK trimmers. And I call it imagine your trimming because it's a lot of things you don't see actually when you trim, and you want to see them. It's inner structures, difficult to interpret the outer shape into the inner structure and inner function. So we'll try to kind of help you today to enhance your imagination in case of hoof trimming. So it's, let's see. So it's basically about this big project which we finished last year, and we're still working with the data. There's a lot of data from the project. And actually, the first time when I talked to UK trimmers, it was we were kind of on the way in this project. And second time was the halfway project, and the third time was actually finished the project. So I can just share some most interesting results. Still, some of them quite preliminary. So it was the three parts of this project. First one, we in the lab tried to analyze their different aspects of the trimming. So we using our machine, we'll talk about just shortly after that. And then we have a field studies when we look at the variation in hoof trimming in Sweden and also the clinical effects of different aspects of hoof trimming, different habits they have in the field. And then actually the third part was to try to develop their audit procedure which ensure the quality of trimming. And I was greatly inspired by your experience in UK, both the positive and negative parts of it. So we tried to avoid some pitfalls that you probably have, but we didn't like enroll it. It was just suggestion how we can do it in the future. But I mainly will talk today about their first two work packages. So about their lab studies. So we have fortune to develop this kind of artificial cow, this ex vivo model of the hoof, which we use the slotted feet, and we try to emulate their kind of position and kind of biomechanical situation of the statical biomechanical situation of the living cows. So we pull some tendons and we make some loading, and we actually managed to put the sensors, which was the first time in history, we put the sensors inside the hoof capsule, so in the sole, so we can actually visualize this pressure from the pedal bone to the corium, and then give us better information how it feels inside the hoof and how it's actually feel to have different type of shoes and different type of floors. Shoes, I mean hoofs, of course. When I talk to the shoes, that we as a humans, we have different footwears for different purposes, for different surfaces. But what is similar that we should kind of feel quite comfortable. So the inside feeling shouldn't be that diverse, that we have different shapes. And in case of cows, so we also have to kind of find out what kind of shapes of the hooves will be kind of provide the most natural comfort, inner comfort for them in this kind of unnatural environment. And what this inner comfort, the gold standard for this is, of course, this natural surfaces. And it's not just pretty picture of cows on the pasture, it's a particular cows which we actually use in our experiment. This is a free range farm in Sweden, quite unique for the Swedish conditions, so they don't have kind of any housing, and they don't trim and then don't walk on concrete. And it's a bit sad story because for them, because they situated in the south of Sweden and then use a lot of pasture area actually owned by Swedish military, and now because of this Russian threat, they started to exercise more about their tanks on this area, and they have to kind of move cows from there, and therefore they was forced to slaughter a lot of quite healthy animals. Unfortunately for me, so I can get the very healthy hoofs, which were developed under the very natural conditions. So this is example of this hoof of a three lactation cow, never trimmed, never contact with the concrete, and the grass actually very good kind of ergonomic surface for the cattle, because it's not only kind of providing a good cushioning, but also good support for the walls. So it's like good ergonomic shoes, which is not only soft, but also have to provide a good support for the feet. And it's interesting also that you see that they're on the natural surfaces, they will sink their toes, which result in different positive things, but mainly that their toe angle, the real toe angle, will kind of increase. So the 7 millimeter sinking in the surface will be resulted in like 5% extra degrees in the hoof angle. So it was good, and it's an increased hoof angle because of release the pressure from there. See if I can get a pointer. Yeah. So from the inner structure here, and also will be more efficient for the, like, for example, deep digital flexion tendon to be more efficient as a part of the suspensory apparatus within the hoof capsule. So it's kind of just only slide slightly along the navicular bone, and it will be more efficient in flexing, but also lifting a bit pedal bone here. And see how beautifully developed their digital cushion in the hoof. So, and the good sole thickness, it's like beautiful hoof, functional. So it's kind of see that there is this very natural surface. We have this kind of jeopardizing the role of hoof trimmers, because probably they don't need them, you or us, if they have a very kind of satisfying environment. So we measure the pressure in this borderline between the sole and the corium. You see, we just put a kind of part of the posture in the lab, and we look at the pressure distribution of this natural hoof on the natural surface, so it's on the lateral claw here. So we see it's very good distribution. So the most the forces most pressure goes towards the weight-bearing edge, to the walls, so inner and outer wall, and no high pressure peaks within the sole. And also the weight distribution we see quite equal between like approximately like 50% between the anterior and posterior part of the foot. So it's a good unloading of this critical part of the hoof. If we compare with the hoofs which are developed on the concrete, like this one, so you see it's a different situation, and we see that the digital cushion is not that fatty here, so this is replaced with more fiber tissue, and concrete's obviously not damping and still good supporting. So we have this backwards rotation of the pedal bones, where we kind of supposed to have this overload of there's more sensitive parts in the hoof. So if we look at the pressure in this border part again, so we see that the weight distribution is quite uneven. So we have a lot of weight concentrated on the back part of the hoof. Therefore, we trim them, so restore this good distribution. But also we see how the walls are excluding from the weight bearing quite a lot, but not some part of the walls are actually quite loaded. So, and it's not the strongest part of the wall. So close to the abaxial groove, we have this overload of the pressure overload of this abaxial wall, which is weaker part of the abaxial wall, and is prone for for example, white line abscesses. But also in the central part, we see the higher peak loads from peak pressure from the pedal bones. So we see that the flexor tuberosity kind of makes this kind of extra pressure there, and they provide us a higher risk for hemorrhages or cell ulcer. So, and therefore we trim them. And to unload this central part of this, the idea was quite recent. That was quite hot topic in Sweden, like 5 years ago. What kind of model we should use, and there are some just to unload this critical part of the sole, and there are some studies published, not 100% convincing how the model should look like. And just recent published paper this year started, but they published their PhD studies like 6 years ago, show that there's a good clinical effect of the big model for the less hoof-horn lesions, but mainly in the young animals. And with all the animals, not that good effect, and there are some suggestion why it should be. And we also gone through such suggestions, but mainly the thought will be kind of a lot of pathological changes in the bones, like exostosis, and they provided that it's not possible to unload it. But I have even kind of more simple explanation why it could be like why it didn't work in all the animals. And in Sweden, it was at that time was mainly moderate model was applied, like we model about 50% of the width of the sole. This was what more common applied. But some people started to use this big model as well. So we tested in our facilities, and was just to like explain why we should do it modeling, and how big model should be, just to this avoiding the pressure from flexor tuberosity. So we have to expose and show the people where this flexor tuberosity is. So we just took some hoof from our lab, and we removed the hoof capsule, and I removed the corium from underside, just to expose this bump where this attachment of the deep flexor tendon is. So we see it's quite big, and it's much bigger on the outer hoof than on the inner one. And if we just translate it here, so we see how wide it is here. So it's the top over here, and it's that wide. And you see that anatomically, it's quite logical. It's at the end of the pedal bone. So the pedal bone, we can see the end of this laminar layer is attached to the wall, and with the ends, then we have this spot of the point when we want to unload with the help of the modeling. So we can return back the sole and see where it actually positioned on the hoof capsule. And you see that what kind of modeling you actually need to unload this site. And you see that probably the very little modeling, it's will be not enough, and moderate and maybe just going on the edge as will some shearing forces, and big modeling have a very good possibility to cover all this area. And also you see you don't need actually go towards the wall completely, so it's not exposing that weaker part of the abaxial wall and make kind of more lever effect and provide more risk for separation. So we don't need to be extremely high, but a bit bigger than the moderate will be enough. So we why also was said that usually when people see this, but it's not that this place is not like typical place for soils, or usually it's supposed to have it a bit like lower. So what is interesting, that just to comment on that, because we usually find the sole also about placed forward, not like exactly under the flexor tuberosus side, but a bit forward, and it's can be explained by the direction of the hoof horn growth on the sole. So we see this is like, it's not hemorrhage, it's just pigmentation moving. So you see there's a pigmentation side, and see quite nicely how it's moving forward. Those are the hoof growing and a bit forward. So we kind of, it's kind of misleading when you open this hoof and you see that the so also on one side, but actually the pressure is coming from not exactly the same region. So just think about that. So we have tests with different kind of modeling extent, and also with different angles. And we did quite shallow modeling to also kind of catch with the sensors the shearing forces on a flatter sole. So this is the inside measurements with the different modeling, and and see that the little modeling, like 1/4 off, and was 2/4, or 50%, is like no difference. We will still have this pressure inside, and we can compare also with the untrimmed hoof, which is, we see that we even with the flat trimming, we reduce the pressure from this particular side, but the big modeling actually catching this place much better. So we have reduced this pressure, but the force is still there, so we should go somewhere. So we have some kind of, you see that the posterior part of the abaxial wall will be more loaded here if you compare with these scenarios. So we really just decrease the risk for the sole also, but you probably increase the risk for the white line disease, because its weight should go somewhere. So it's good to combine the big modeling also with the steeper angle. And we use the steeper angle just like by 3 degrees. And to make it 3 degrees, you need to remove about 5 millimeters from the toe. So we actually work with very small margins here, but they're increasing the angle, so that we actually reduce, even with the kind of flat soles here, we reduce the pressure of this critical part. And with the bigger modeling and increased angle, we're quite close to their kind of this picture we saw on the pasture. So kind of we're approaching into this normal pressure diffusion here, and you see how much we reduce the weight distribution when we increase the angle, about the 7 to 10% shift toward the toes due to 3 degrees increase, and this about 10% increase of the load toward the toes provided quite good release of the maximum pressure on this particular critical part of the wall. So we have the 10% shift towards the toes, but we have the 26% less pressure here compared with the lower angle. So it was a good thing to show that the big model actually worked quite good, especially with the combination with the steeper angle. So it was like positive. But now I will show you how the big modeling can be also have some negative effects. So here's the 2 hoofs. You can see both will be benefit from trimming. And the first steps will be kind of see what the difference between them. So we see a kind of reduction of the bulbal horn here, quite common. You can see here in Swedish cubicle farms when they have a hill erosion. So they lose the horn. So you see that's the difference here. So with the first steps will be quite similar. So both the toe length and the angle will be restored, but then we have to proceed with the modeling. And it's quite simple here. So we see we place it. Like here we have good support from the heel, and we unload this critical part, the flexor tuberosity. So will be not squeezed between the sole and the surface. But here there's a risk that the people kind of interpret that this is the back edge of the heel. So there is a risk that they will move it a bit more to the toes, and then will not completely unload this critical part, but rather because of the bigger modeling, it will be a much smaller area, and quite high load will be concentrated right there. And actually did it by mistake myself, and then I thought, why didn't my modeling in the lab really unload? We still have this high load, and then we test with our hoof trimmers with their workshop. So we trim the slaughter hoops, and then we split them with the sagittal cut, and say that with all the hoofs with their especially prone with the sole heel erosion, that they was quite prone to moving this modeling towards the toes and not really unloading this critical part, but it will be kind of high load there. And it's illustrated here, like there is a trimmed foot pressure image. This is a flat sole, so we see some of image of the flexor tuberosity here, higher pressure there. And then we have the big modeling, so we unload this part. This is a very nice place, and we see that the pressure goes towards the walls. And then we just suppose on this hoof didn't have heels, and we just slightly move the modeling toward the toes. So you see extremely high pressure there, and also on the walls there. But if you don't model at all, with no heels, you see this kind of picture. So this pressure is actually less than this one. So this is a worse situation. So this hoof will be benefit not to be modeled in this particular situation. So this is like lowest pressure, this is like second place, and the third and like highest will be here. And we can just put it like you see. So it's not exactly under, so it's just still sharing there. So it's not this modeling only slightly shifted, not entirely outside the flexor tuberosity, but still we have this higher pressure there. And I thought what we can do with this kind of hoof is kind of provoking hoof trimmers. So some tell me that if you have no heels and low angle, so we can't do a really good job with that. So I kind of provoked it. So I make some provocation myself. So I just put them on the soft wedge shaped blocks, where I thought this cow will be benefit to go on the pasture. And the pasture we have the steeper angle and we have a softer surfaces. So we kind of imitate in pasture and put the both digits on these blocks. So it was in the lab, not living cows. But then the pressure went much better. So see, we release this pressure from this critical part, and we have a good load on walls. So it's not like I recommend to put all the cows with the heel erosion on blocks, but this was just the illustration what we can do about different situations and how it works. So then I did quite many tests on request by Swedish hoof trimmers. We have very good discussion with all these meetings with them. So I never missed any meeting, yearly meeting with them. So for the last 5 years. So they kind of inspired one talk about the Kansas method. So we're interested what the effect they have when they make this inclination instead of make it this perpendicular to the axis of the bone. So we just ran small tests of the different inclinations of the feet from like 2.5% inclination to 7.5% inclination with different kind of height difference between them. So we see what we see here is actually that the digits are quite rigid due to very many ligaments across them. So they are not really moving then when you have a very big inclination. So the inner wall will not land then on the surface, but the small inclinations actually looked like quite beneficial because we have a good shift towards the abaxial edge. So we have this. So it can be a bit beneficial, but it's not like you still have to take care that the outer wall is kind of still perpendicular to the surface, not very big angle. Otherwise, it will be much stress to the white line for white line separation. But it's also kind of interesting discussion here without this small inclination. It can be beneficial, and maybe it's a kind of, in some cases, it can be alternative for the modeling when you cannot apply good modeling due to initial conditions of the hoof. So at least you can see that you move extra load abaxially from the axial edge, from the inner edge to the outer edge, and by this you decrease this extra load from the pedal bone toward the sole. It's another experiment they want me to see that if you have a higher axial wall, what we get here, because some trimmers that will get the bit higher axial wall after the trimming and then will kind of balance by themselves. But immediately after the trimming, you see that it's not very pleasant thing happen because the pressure will be bypassed the strongest part of the axial wall and land on the most kind of weaker part of the wall. So it's not that positive. And then but how long it will be last. So, and that was another question which we have to test about the different unevenness after trimming, how long it will last, and if they have any effect on the hoof health. So how is important unevenness? So then I analyzed our very old data when we have long-term effects of different flooring systems. And we test then very many cows before and after trimming with the pressure sensors, cows staying on them. So it was some results we could analyze, and we look at 113 cows trimmed close to calving. It was under the condition of the one experimental barn in Sweden. So we tested after trimming, we test the pressure distribution when they're standing on the pressure sensor. So we could register different higher points, pressure peaks after the trimming. So we can see like this after trimming some hooves were not very high peaks and some very high peaks. And then we were distributed on different flooring systems. Some of them went on the alleys with the rubber mats, and some of them went on the slated concrete with the older concrete, which was hard but not very wearing, not very abrasive. And also some part of it went on the alleys with the mastic asphalt, which was quite abrasive. So it was the highest wearing rates there and quite low wearing rates on the concrete. And we, after some period, we looked on the hoof health and checked the prevalence of the sole hemorrhages, and we look on the moderate and severe hemorrhages. We didn't use the very small hemorrhages there. And there was no difference between the prevalence and with different floorings here. So it was even slightly more, not significantly, slightly more was on the rubber, the hemorrhages, than on the harder floors. But the effect of the higher pressure peaks on appearance of the hemorrhages later on was higher on the hard floors, regardless of whether it's abrasive floors or not abrasive floors. Also on the asphalt and the concrete, we have a better estimated risk of having hemorrhages due to having the higher pressure peaks after trimming. So we have a higher odds for moderate hemorrhages with the on the hard floors, but on the soft floors. So the soft floors kind of buffer and it's kind of more forgiving for trim mistakes. But it's interesting that this unevenness have an actual effect on the sole hemorrhages. So, and there are some other results which we back to our ex vivo models. That was a good illustration of the inner pressure and different mistakes. So we can allow us to do a lot of mistakes when we test dead cows. So it's an effect of the removing different part of the walls on the pressure distribution. And we see that the mainly negative results were when we remove the walls around the toe triangle. So then the quite harsh increase of the pressure towards the pedal bone in the toes, because the pedal bone is totally relied for weight carrying only on the walls, because they miss their fat cushions in this area. So it should be only coming from the walls. And when we remove them, then we get the pressure towards the corium directly due to pedal bone. And of course, when you remove all the walls around, you see that the pressure will go directly to the pedal bone. That showing that the importance of the walls, especially on the harder surfaces, so they have to support the weight. And to the field studies, so we should, if we are doing well, if it's our lab findings actually supported or is it contradicted with what we're doing, what they're doing in the fields. So we follow this 19 certified hoof trimmers, which is roughly 19% of the older certified hoof trimmers working in Sweden. So we're roughly 100. And we collect a lot of measurements, how they trim the cow. So we, by measured 20 cows per trimmer, we collected 20 objective measurements of hoof shape and 16 subjective visual characteristics. Well, we collected much more, but we selected them as more relevant subjective visual characteristics of the trimming. And there was some complicated multivariate analysis to create the profile, how they trim in general, like not only one measurements in a row, but how they combine different possibilities. And this is my good co-workers, Frida Öckerström, which is also a PhD student, and she was out on the farm and collected, and Ann Newman from Växa, she is an epidemiologist, and she's responsible for all these complicated statistics, because of we can combine their different trimming profiles with their registration in the field. And in Sweden, we registered like more than 80% of the all cows trimmed, and these certified trimmers, they registered all the cows they trimmed. So therefore, we could combine this very big data with their profiles, and it resulted in more than 400 herds and more than 52,000 cows, which included the analysis. So they were trimmed 2 times, like first time they trimmed, and the next time they trimmed and registered the hoof health. And of course, this analysis we can rely on this analysis only as providing this. We have 2 assumptions that the trimmers actually keep their trimming profile. And we realized that there are some 4 main profiles, but also some people also combine some at least 2 profiles at the same time. So they're not that stable, but still some was quite quite consistent. And also the good agreement on the health registration, because we relied on their own registration. So the hoof trimmers register the hoof health, and therefore we only use the severe lesions, because we are, according to our earlier studies, which we could see that there are quite a disagreement when we try to analyze the less severe lesions like heel erosion or hemorrhages. But when we go to like abscesses or sole ulcers or severe digital dermatitis, then they agreement much better and satisfying. So here's some very simplified results for this complicated analysis. So it's a group, and kind of this is aspects of the trimming that characterize the group which resulted with the less severe lesions. And this group have a relatively big modeling. Well, most of them were quite wide, but especially compared with the other group, they were deep modeling. And they have a steeper toe angle, like 50 degrees or greater. And toe length, it actually doesn't matter. They're both characterized with the long, and some of them profiles characterized with the shorter length. But was a greater sole thickness. So it's mainly thicker than 6.5 millimeters. And we measured the sole thickness with the ultrasound with this when we constructed their sole profile, hoof trimming profiles. And we also saw that the bulb horn was often trimmed on outer claw and seldom on inner claw. So it was also related to their greater sole thickness. So they save the inner claw in greater extent just to make the balance between the digits. And their model seldom involves the axial wall. So axial wall is quite well preserved here. So it not goes much to the toes, but also interesting that they also modeling often placed high, quite high, involving bulb of the outer claw. So like this or like this. So they model a bit above, well, across the bulb. And when we just created these different categories, we thought it will probably a mistake, because you don't need to model of the bulb, because there is no bone there under, so you kind of decrease their cushioning effect. This is the stroke absorption of the hoof. But that probably when they do like this, they also kind of more keen to not to move the modeling towards the toes, and then they have a better opportunity to release this higher pressure flexor tuberosity with this kind of habit. So when we look at the group which are characterized with the more severe lesions, we have more of them have a shallow model, like this. So it's hardly modeling there at all. And it's also kind of reflecting that the main habits of Swedish hoof trimmers, that they usually don't use knives with routine trimming at all. So they want to do everything with the grinder. So some of them not daring to kind of go with quite deep modeling when they use only grinder. And we also get this group with the lower toe angle. Most of them were characterized with the short toes. So the shorter toes, but lower toe angle. And also smaller sole thickness. So quite often it was thinner than 6.5 millimeters. And where some of them were characterized with a slanted toe like this. So they go quite aggressively and remove quite a lot of wall here from the axial edge. They were more keen to preserve the bulbs. We thought it could be positive, but it's also involved that they're modeling more towards the toes and take more modeling over their axial wall. And it's also reflecting that they usually only use the grinder. So if the grinder is a certain diameter of the disc, so they want to preserve the bulb, they will go more down to the toes and remove them more from here. And you see here, probably they will not like this example will not very efficiently unload this flexor tuberosity site, which you see that the walls goes here. So we probably will be like here. So it's not modeling. So they're preserving bulbs, but they're not kind of reducing the higher pressure. Still using kind of bigger model, but not reducing much pressure from the critical part. Thought that was small results from the big, yeah. So both this bulbs not trim and modeling of axial wall, which kind of characterize the lower place model. We can see which can be the risk for the higher pressure peaks. So we have a plenty time for the questions, but now my takeaway messages here. So we find this big model adaptation is quite good to effectively release the critical part of the sole, potentially preventing sole ulcer, but it should be combined with the steeper toe angle to decrease the load on the rear part of the axial wall to decrease the risk for the white line disease. And also we saw that the shifting of the big model towards the toes, for example, due to heel erosion, may result in excessive pressure to the corium. Instead of releasing pressure, we're actually increasing pressure because the weight should go somewhere, and we just decrease the area of the contact area. So we leave the contact with this exactly place when we want to relieve. So it will be not very positive effect, and that probably kind of can explain why all the animals were not so benefited from the big model, because they didn't register how the placement is only the size. But if there was a place like more towards the toes or not, because we saw like in our trimmers, when you don't see, so they kind of keen to put it more down to the toes. So when we cut of the trimmed hoofs, dead hoofs, so many of them were quite surprised that that's sitting that much backwards, more backwards than they thought it will be. And field studies also indicate that trimming with the steeper angles, thicker soles, preserved walls, and deeper and wider and more precisely placed modeling associated with a lower risk of severe hoof lesions. And it's quite pleased that we didn't contradict with our lab studies, but it's also showing that there is like no extreme big surprises, so which know how to trim as well. So it's not big surprises in the results. So we kind of knew it before, but it's good to get it on paper as well. As I also want to encourage when discussing the best hoof trimming technique, it should be more focused on what we can improve on these particular animals with this particular situation. So we not just blindly apply this general method, but we'll see just more to think how this biomechanics actually works and what we can do on this particular animals in this particular farm, in this particular management, so we can just decrease the biomechanical risks and not increase them. That was my point for today. And it's kind of can be considered as difficult and maybe considered as mission impossible. But I'm very impressed how you can actually perform your work in the field and actually make it quite correct guesses. So when we split the hoofs after our very professional hoof trimmers, you will see that they keep good hoof thickness and provide a better angle, and modeling quite often were in the right place. So it's quite impressive. So thank you for today. I'm looking forward to see some questions and inspiration for the future work, and hopefully I can also be and live because I want to see the people. So it's kind of talking to myself. Hope you could hear me as well.
Thank you very much, Evgeny. That was really, really interesting. I think first I'll go to the questions that are starting to kind of come into the chat. There's a couple of kind of questions first from Tim. Going back to your slides where you compared the different model sizes at a 49-degree and a 52-degree hoof angle.
So we can go back to this.
Thank you. I guess the first part of the question is: was that only done in cadavers, or was that done in any live cows?
That's on cadavers. Yeah.
Okay. So
because this is the pressure on the inside.
Yeah. Okay.
And we don't do it in the live cows.
Was the toe length recorded in those cows as well? And I guess, do you have it? Do you know it, or is it recorded somewhere in the depths of data?
Yeah, we have it, but it's like. Yeah, but they also trimmed with the blunted toe, so the toe length was like the same. So we just decreased the angle only. Yeah.
Okay, cool.
It's quite common. Like nobody in Sweden trim with the pointed toe. Mm-hmm. I haven't seen it. So they always with the step. Right. Therefore, you see that there was no connection in the walls there and on the tip of the toe here.
So yes, yeah, of course. Okay, thank you. And then a question from Gemma. Great talk, thank you. Does sand bedding alter the way weight is distributed too? Are there any studies looking at sand bedding and corkscrew claws?
Good question. I try to buy all. It's always a question from the Nick, I remember. So every time I show this, you should tie with the corkscrew and say, you know how it's time-consuming and labor-consuming just to prepare one foot, just for the good sensors, and then I need kind of prepare very similar corkscrews just to see some effects because it's kind of also foot dependent. So we have a different progression of corkscrews, and it's also because the corkscrews they are not kind of parallel to the ground as we know. And it's difficult for me to measure because the pressure, I can measure only kind of vertical pressure, but not horizontal forces. So I try to do it more clinical studies on that. So I'll not do it.
Yeah. Certainly be really interesting though. Yeah. I've got a question if that's okay. And this is on your comparison of your trimmers when you kind of identified the features that came out of your modelling, and you noted on this slide you kind of noted that long toes could be long or short. I guess is that long or short compared to cow size or just among them. But we also measured the before and after trimming, so how much they shorten the toes as well. But it's also these results were mainly it's only for the preventive trimming. So with the results with the hoofs, with the lesions we didn't use to creating their profiles. But the results is showing that the toe length is not that important unless the angle is right. But I kind of noted that obviously the angles, the point that's also in that
the
model,
angle and the angle and the sole thickness was very important for these profiles then.
Yeah, which I guess is all sort of related in the average cow.
Yeah.
Okay, brilliant. Thank you. Are there any more questions out there? There's nothing else in the chat, but does anyone want to unmute themselves and any comments or questions?
Yeah. Hi, Jay. Can you hear me? Hi, Evgeny.
Yeah.
Hi. I can hear you and can see you as well. That's nice.
Yes. In your last set of slides, second from last set of slides you put up, you didn't trim up into the heel bulb.
Yep.
We find out, or I found personally over here, that we get a lot of hemorrhaging in and around that heel bulb, so behind the flexor tuberosity site.
Yeah.
And if we don't remove it, we tend to find cows go lame up in there. I just wondered whether you came across that in any of your studies. Just looking at some of the pictures, there was a 1 foot that had a bit of hemorrhaging up in and around the heel bulb where it had been removed.
It's probably here. Yeah. Yeah.
Yes. So the one down in the bottom,
like there. Yeah.
Yeah. So we get quite a bit of that.
Yeah. So it's actually the flexor tuberosus is sitting quite close to that side. Yeah. And especially when
Yeah. Sorry, you were saying earlier on your cadavers that you dissected and you showed it perfectly, the flexor tuberosity site. So that in that picture it would have been a little lower down towards the toe there, wouldn't it?
Yeah. Let's see. This one. Like this. Yeah. You mean this one?
Yeah, no, before that, in your when you took the soles away. Yeah, it was a bit earlier than that. Yeah, it doesn't. Yeah, I just
this one.
Yes, so with there you showed no heel support and no models. Yeah. We've got a pressure point back.
Yeah, you have a higher pressure point here than there because here is still distributed over the bulb. Here's the bulb is reduced, so we have the higher pressure from here. But this kind of better pressure distribution that was much higher because it's a smaller contact area here. Because that's a modeled, and then you have this high smaller area and the same pressure, so it's kind of higher pressure there.
Yeah. Okay.
It's just a model, so it's this. We assume they don't have bulbs. Do you demonstrate that can be higher pressure when you want to release the pressure, and then it'll be higher pressure instead.
Yeah.
If it's positioned strongly. Yeah.
Yes. Yeah. No, I get what you mean. Yeah.
Awesome. Thanks, Tim. Any other questions out there? Grand. If there's nothing else, then I think it's just for me to say thank you, Evgenij. I think it's really appreciated that you've come back again to speak to us. And I think we would echo your points that it would be good to have you in person talk as well, because I think there's always a good bit of chat around the back of that then and get you involved in some of the other conversations going on as well. That'd be really good. But
because
for now, thank you very much.
Yeah, I promise to come back. Yeah, wait a minute. I will to.
Yeah, thank you very much, Evgenij. That was brilliant as always.
So, you can see me now.
There we go. Grand. I think then before. Sorry, go on. Yeah, before we let everyone go, it's probably worth me mentioning tomorrow's guest speaker, who's going to be joining us at 3. So Drew Schwartz. So Drew's an assistant professor and extension specialist at the College of Agriculture and Natural Resources at Utah State University. Undertaken an MSc providing some insight into automated milking machines and a PhD looking at camera-based systems for detecting hoof lesions, as well as also looking at some of the barriers that people have to adopting the automated methods. And he's going to talk about some of his work and a bit more as well at 3 tomorrow. So yeah, if you've not already signed up, please do sign up to that, and hopefully it'll be recorded for those who can't, but please do record in advance so you get access to that. So that's all I've got to say. Unless anyone else has got anything to say, then I think it's just, thank you very much, Evgenij, and hope everyone has a great rest of the day. And I will leave you all to it. Thank you.
Thank you.
Thank you very much.